Okay, so negative pi over 2, 2 pi over 2. So those are the ones that we talked about in trig already. And also we talked about that from last week. So anytime they recognize the parent graph, so basically you can sketch the whole function. Doesn't matter how complicated that is, we just put it into one cycle, right? And then cotangent. So cotangent is started at 0, right? VA. And then finish that at pi. Cotangent, what does that look like? Reflected cubic curve, right? Like the reflected tangent curve. So we got tangent, cotangent, sine and cosine. What about for secant and cosecant? So for secant, it's based on the graph of what? Cosine, right? So that one is just like a parent graph. But the thing is that for secant, it's just like parabola, right? Like a bunch of parabola. What happened at 0 here? What's the reciprocals of 0? Undefined, actually. It's 1 over 0. Right. So that's why it goes this way. In calculus, we'll talk about that 1 over 0 something. So it's going to be like infinity or negative infinity. So one is going this way, and the other one is going like this. So here's pi over 2, pi, and then 3 pi over 2, then 2 pi. So you can write? Actually, I put it the arrows too. Okay, so now what else? What about for cosecant? What does that look like for cosecant? Cosecant is based off the graph of sine, right? Yep. So VA. Oh, this one is actually just the y-axis. So we got a VA right here in the middle. And then, oh, this one's supposed to be V as well. That's right. Then up 1, down 1, parabola. Okay, so just like this. Okay, morning. Okay, so any questions I have so far, the way that we sketched the parent graph? Yeah? So I guess this is all ready? Yeah, it's good. It's just a reflection, okay? You have like different pages. Like Washington, the teachers skip what? Log, polynomial, chapter 3 and 4. And you guys pretty much follow through the process?
My teacher just through the regular order.
Yeah, that's what I do too.
We'll be starting with matrices and we'll be not sure what chapter
that is. That's actually like chapter 9 or 10. Don't worry about matrices, we covered that already. But it's going to be a basic matrices. How is it? Yeah. Chapter 6, that's about like what? Law of sine and cosine, right? Yeah. So you guys okay so far? Okay, so now guess what we have to do today? So the packet, I'm sure that I gave you. Did I give you this last week? It's what I did here. I just used that the honors facing, so that's why the chapters, some of them being combined together. Guess what? Chapter 5. That was chapter 4, the graphing one. Probably not. I didn't give you that yet. Yes. Yeah, that'd be great. Not necessarily. Not necessarily, but it's good to know. Do you know what that is, Kentika? Newton's law of cooling? We'll talk about that, right, already? So the Newton's law of cooling, let's go over that again. So it shows the rate of change, right, of the temperature of the object, dt over dt. So that's like directly proportional to the initial temperature minus the surrounding temperature. So for calculus, if you try to integrate it, so the formula is going to be like T of lowercase t, and then it's T minus Ts times e to the power negative kt plus Ts. Right? We talked about this already. Yeah? DT? On the formula quiz, the one that we did last week? Yeah?
But then does calculus, no, does.
I don't know. But I actually covered that in Kennedy, in case that's going to be on the SBAC. But for calculus, for sure that we're going to do it, because this one shows the rate of change. That's the derivative in calculus. So once you integrate both sides, eventually you're going to end up with this. But for calculus, we'll talk about that. I'll show you the derivation, the way to integrate it. Okay? So that part is like a Cal BC stuff. Okay? So now, what do you notice about the Newton's law of cooling? Well, T, that would be the initial temperature. So let's say that you took out something from the refrigerator. And then Ts, guess what that is? The surrounding temperature, right? The room temperature. Well, this one is not just about math, it's for science, And then negative K, that's just like a constant rate. Okay. And then T, the time, obviously. Again, Ts, the room temperature. And then T of T, that means the final temperature. Okay? Makes sense? What happens if you take out something from the refrigerator? Yeah, warming up, right? What happens that if you take out something from the oven? Start cooling off, right? That's why it's called the Newton's law of cooling. For science, I don't know. If you're taking like AP physics, the teacher probably talking about that too. Without the calculus part, just the algebraic part. If you're taking AP physics, physics C. Yeah. Or you're taking like, Cal 3, we don't talk about that in Cal 3. That's what physics is. You guys taking that class next year? AP physics? Not sure?
It's a lot.
Yeah?
Oh. The hardest.
There's no more BC, right? If you guys, is that true? You're saying that there's no more BC at Irvington?
If 30 people sign up for it, it reopens.
No, next year. Take that at Kennedy,
It's a lot.
but you don't want to go to Kennedy. Well, in the past, we did have people like transferring to Kennedy from Michigan. Really? Oh, yeah. Like 2 years ago, I do have like 1 or 2 students. No, 3. He actually transferred from Irvington to Kennedy. Just want to get more credit, like taking classes faster. We also have a lot of AP program, a lot of good AP program. The teacher, they're pretty good too. If you try to compete against the student from Kennedy, you guys are going to be the winner. Because those guys, like, people are taking AP classes, they're not like the truly honors AP student, The admin, the counselor just want to push the student to, to take like challenging courses. Some people are, but not like everybody. Yeah, kind of. Okay, so anyway. Okay, so now, and you guys ready for the packet? What is that about? Hardest stubbing trig. What's the hardest stubbing trig? Proving trig identity. And that's what we're doing today. Okay, guys, take a look at that. Study packet. Okay, guys, what are those identities again? Let's go through that, the basic one first. Pythagorean, what are those? 3 Pythagorean identities. Okay, so if you guys just checked out YouTube video, I actually showed the proof about this. The unit circle. Did you guys watch that? No, probably don't have time. Tangent square of x plus 1, so that equals what? Secant square. And then the other one, cotangent square of x plus 1, which is what? Cosecant square of x. Okay? Pythagorean identity. What about the other basic identities? Like the ratio identity. What are those ratio identities? Anyone? You guys, you recognize them? So tangent is just like written as what? Sine over cosine ratio, right? So just rewrite it in terms of sine and cosine. And then what about cotangent? Cosine over sine. And what else? Anything else that's involved with ratio? Okay, well, the rest of that it would be what? Reciprocal, right? Reciprocal identity, so we do have secant, which is 1 over cosine, right? According to the graph. Then cosecant, 1 over sine. Now, here's the one a lot of people are having trouble to deal with. Cofunction property. Cofunction identity. What are those cofunction identities? You guys know? So let's say like if you're doing sine of theta, which is the same as cosine of 90 minus theta. Right? It's just like a complementary angle. Why is that? What's the sum of all the angles of the triangle? 180. If that's a right triangle, so 180 minus 90, so we get 90 again, right? So 90 minus one of the angle, so it's the same ratio. So the same thing happened with that cosine of theta. So sine of 90 minus tangent. Yeah. And also even function property. What are those even function identity? So cosine, which is the same as what? Cosine of negative theta, right? Even functions. Yeah. And then sine. Well, sine is not even. Sine is odd function. What else is considered even function? Since cosine is being considered an even function, what else could be considered an even function? Secant. So secant of theta is the same as what? Secant of theta. So let's say that you want to evaluate secant of pi over 2. Same as what? Secant of negative pi over 2, right? Yeah. And then the odd function identity.
Sine and tangent.
Yeah, sine, tangent, the rest of the trig functions. The sine of negative theta, which is negative sine theta. And then what else? Cotangent, negative theta, same as negative cotangent theta. Yeah. And then cosecant of negative theta, same as negative cosecant of theta. Yeah, let's see what else is missing here. Tangent. So tangent of negative theta, same as negative tangent theta. So those are just the basic identity. But once you get into double angle, half angle, sum and difference, then that's going to be more. Okay? Or the product to sum, sum to product. So we'll deal with those later. So now on the first page. Okay, so now let's write some of this. So simplify each expression to its lowest term. And then write the answer in part B as the product of the factor. Okay, so what do you have to do? Simplify it to the lowest term. Well, let's try the first one. Okay. So anytime that you see anything like sine, cosine, every trig identity, every trig function involved, that means you want to rewrite it in terms of sine and cosine. So the first one. Okay, So what would you do? So sine of x minus cosecant of x over cotangent of x. Any trig identity that I can apply? Ratio, reciprocal. Well, sine, nothing we can do. Leave it. What's cosecant? 1 over, 1 over cosine or sine? What about cotangent? Ritika, what's cotangent of x? Cosine over sine. Okay, guys, back to algebra 2. What do you notice? Is this considered a complex fraction? It's like a fraction within other fractions. So what would you do? Multiply by the reciprocal. We can do that. Or we can rationalize it. Can we just multiply top and the bottom by sine of x? LCD, least common denominator, top and the bottom. Check that. Yeah, you can do that. But instead of going that way, so multiply top and bottom by sine. Right? What's sine of x over sine of x? Just 1, right? But it thinks that we want to change the expression. So sine x times sine x. So sine square of x. And then 1 over sine of x times sine of x. That's just minus 1. Denominator, cross cancel. What's left? Cosine x. Okay, so now from here, what else can we do? Wait, sine square of x minus 1, is that cosine square of x or negative cosine square of x? Can we apply the Pythagorean identity? It's negative, right? It is. Well, why? Because of this. Pythagorean. So sine square of x minus 1, what happened if you just swap those terms? You change the sign, right? So now what else can we do? We end up with the exact same trig function here. So one is squared, the other one is linear. What can I do? Can I reduce it? All right, Ethan? Okay, so now, can you guys try the next one? B. Hey, what's that symbol right there? Do you know? 1 plus sine, it's a Greek letter. Looks like alpha, but it's not alpha. You guys know the name of that symbol? Kind of like a T. It's a Greek letter. It looks like that one's called sigma. Okay, it's just a Greek letter. So 1 plus sine of sigma plus cosine of sigma, quantity squared. Okay, so what would you do? Square, that means we have to multiply it out. Should we FOIL this? Yeah, write it out twice and then FOIL. Yeah. So you gotta do it 3 consecutive times. So what happened after you FOIL them? Anything that's we can combine, cancel. What do you notice? Okay, so this, and then this one, combine them. What else can we combine? Well, one thing at a time, so we got 1. So sine, which is what? 2 sine of sigma. And then what about cosine? 2 cosine of sigma, right? Anything else? What about sine square of sigma plus cosine square of sigma? Is that considered one of those identities?
Yeah.
One, right? Anything else? This. So we got 2 sine sigma. Factor 2 out, okay? Well, looks like we can combine the lines first, right? And we left with a polynomial. 1, 2, 3, 4 terms. How do you factor a quadnomial? Trinomial, how to factor it easily? Take out 2 first. Should we do grouping first before we take out the greatest common factor? Just take out 2. Okay, so take out 2, so 1 sine sigma, cosine sigma, and the sine sigma. What else can we do? Can we factor this quadnomial? Is that possible? You guys see that? Group the like terms. Can I just group this? Yeah? What's the greatest common factor of the last 2 terms? Cosine sigma. Up here. It looks like that part is done, right? But if you think about it, polynomial. So we got 2 times the quantity of 1 plus sine of sigma. So that one took out cosine of sigma because that's the greatest common factor. So now what's left? Did you get what's left, right? 1 plus sine of sigma. Okay. Now, what do you notice? It's the same binomial. That means we can take out the common binomial, right? Then what's left? If you take out the whole thing, what's remain? Well, you've divided. That's what? 1, right? Okay? Yeah? Tedious, right? Now, you guys want to try to see? Can we apply any identity for that? Think about it. So that one is given as was tangent of 2x quantity square minus secant of 2x quantity square. Denominator. But it's the 1 on top. Okay, so think about it. Yeah, Ethan? There's no need to use the calculator yet? is what is written as 1 over tangent of 2x, quantity, well, it's just 2x, minus secant of 2x squared. So any identity that I need to apply for this?
What is it?
Expand it? No, we're not allowed to use the Pythagorean for this. It's not tangent square of 2x. It's tangent of 2x quantity. Secant of quantity. Are we allowed to rationalize this? What's the conjugate of the denominator? Yes. See that? Minus conjugate. So it's always the what? The opposite, right? And for those who might be wondering, why do we need to rationalize? What's the purpose of doing that? What happens once you multiply this? What kind of pattern is this? The difference of 2 squared, right? So tangent square of 2x squared. Minus secant square of quantity 2x squared. Is that considered one of those Pythagorean identity? On the top, just leave it. And Katika, what's that Pythagorean identity again? That's tangent square minus secant square. What does that equal to? 1 or negative 1? Negative 1. So now, what's the final expressions for the? Here we go. Negative tangent of 2x squared minus secant of 2x. You guys see that? I know. There's another way you can do it. You can convert that to what? Sine over cosine, right? And then secant, 1 over cosine, and then combine the like terms. But eventually, you're going to end up with the exact same thing. We can do that as well, because that we can apply the Pythagorean identity. It's easier to put it in without the denominator. If you just write it in terms of sine and cosine, I mean, that's possible. But the thing is that you're still left with what? Cosine down the bottom. Right? It's irrational. But right now, what is that? It's just like a normal polynomial. Okay. Good. What do you think? Tough, right? Tedious? It's okay. So you guys want to try 2b? So instead of doing 2a, let's do 2b. So for the algebraic expression, it's given as 4 minus x squared quantity to the power of 3 half. But the thing is that you want to put in x equal to sine of theta. So how do you simplify that expression? For number 2b. So this one's kind of like a substitution. So Ethan, how do you start it off with that one? Distribute the power? No, you don't want to distribute the power. It's rational. Yep, so 4 minus 2 sine of theta, quantity squared, right?
Oh.
X squared. Power of. Okay, what's 2 sine of theta, quantity squared? 4 sine squared of theta, right? Now, what can we do inside the parentheses right here? Anything that we can factor out? Anything that we can pull out. 4. Got 4 cosine square of theta to the power of 3 half. Okay, so now to the power of 3 half, in terms of radical, what does that mean? Square root and what else? Cube it, right? So you want to cube the whole thing? Well, let's take the square root of this first. What's the square root of 4 cosine square of theta? Okay, so 2 cosine of theta to the power of 3. So eventually it's going to be 8 cosine cube theta. It's monomial, right? So what do you think? Okay? Yeah? Okay, so now 5, 6, and 7. One of them. Which one was the most complicated to you? 5, 6, or 7? They're pretty similar. Number 7, I think we did something like that earlier. That one just like factoring. Should we do number 6? Verifying. I think. Okay, let's see. Yeah, it's about the conjugate, right? It's all about the conjugate. So this one is just like the basic identity, sine, cosine. There's no tangent, cotangent, secant, cosecant involved. For number 6. But the thing is that, how do you prove that the left-hand side is the same as the right-hand side? Verifying, that means you want to prove, right? So you want to show both sides are equal. So sine x, cosine x. Well, that one eventually will be 2 over, it's negative 2 over. Is there anything that we can do here? Do I need to rationalize it? What's the least common denominator on the left-hand side? What do you notice? Are they considered conjugate of each other? Yeah, so that means we need both of them, right? So sine x minus cosine x and sine x plus cosine x. Okay. Sine x minus cosine x and sine x plus cosine x. Both of them. So anything that's missing here, top and bottom, in order to go from the original binomial to the product of the binomials. So what do I need to multiply top and bottom? Wait, this one, well, we need the conjugate. We need a plus, right? So that one is just sine of x plus cosine of x, quantity squared. Hey, what about the other expression here? What do I need to multiply? The conjugate, right?
Yeah, it's just like
Just the conjugate.
quantity squared.
Yeah. Same denominator. What can we do with those two numerators? What happened once you combine them? Well, this one is sine square of x plus 2 sine x cosine x. Because you want to expand it, right? Plus cosine square of x. The other one is quite similar. That one is 2 minus 2 sine x cosine x. Anything that we can combine, cancel?
2 sine.
What do you guys notice? We got sine square of x plus cosine square of x. Sine square of x plus cosine square of x. Which is what? 2. Denominator? What's the denominator? That's just like sine square of x minus cosine square of x, right? Back to what we got on the right hand side. It's getting very close. What else can we do? Swap the terms, right? So negative 2, then cosine square of x minus sine square of x. Yeah. Leave it up. What do you think? All right? Yeah? That chung level? You want to do the one that chung level? All right. Let's see. How do I get the negative? Because what I did here, I just swapped those terms. Right? Because once you swap them, you take out the negative sign. Right? Can you guys try number 8? If the sum of the angles of a triangle x, y, and z is pi, well, which is 100. Yeah. And then simplified expression of secant of x of sine of y plus z. That was kind of tricky. Yeah. Later today, there's some of the problem here with identity. They even like parted and trunks. You'll see that on the next page. Again, the condition is given, x, y plus z is pi. So how do you simplify the expression? Secant x. And then times sine of y plus z. Think about the cofunction property, the one that we talked about earlier. This one is just the fundamental trig identity. Okay, so it's written like this. What's y plus z? Can we rewrite it as pi minus x? Yeah? Does that work? Using the cofunction property? Well, this one's kind of like cofunction, but it's not supplementary. Is that tangent x? Let's find out. What's sine of pi minus x again?
X.
In terms of cosine?
Just sine x.
Remember that we talked about earlier today? This one is the same as well. So that one is just like cosine of x, right? Oh yeah, that's right. It's just sine x, right? Yeah. Uh-huh. Right. You're right. Using the reference angle. Reference angle. Is that because the reference angle is right here? Right? So 180 minus x. Okay, so now just tangent x. The secant is what? 1 over cosine. Cosine over cosine. It's not that bad. But what about for number 10?
Angle double.
We're not using those identity yet. Assuming that you don't know about the half angle and the double angle. Any thought? Cosine of 110, cosine of 70. Okay, we do have this.
No, it is.
This one is just using the reference angle. What's the reference angle of 110? Cosine of 70 also? But the thing is that it's minus. What's minus? It's in the second quadrant, right? So what's the answer? What's cosine of 70 minus cosine of 70? Yeah, right? Such a tricky one, right? Again, it's all about the reference angle.
Yeah.
The positive, positive, over here, negative, positive.
So the
See that?
pi minus x only works for sine. That doesn't work for cosine.
Yeah. Yeah, this one's right, because that's in second quadrant, so that's why it's positive. So for cosine second quadrant, what's negative? What do you think? All right? Yeah? Okay, so now let me pick the one that's harder. So that's another proof for number one on the next section, for the one I would like to do for the next part. Can you guys do number two on the top of page? Page 2. So verify tangent of y over 1 minus cotangent of y plus cotangent of y over the quantity of 1 minus tangent of y. Then you want to show that it's the same as 1 plus secant of y times cosecant of y. That one looks tough. You tell me, which one looks more complicated? Yeah, the right-hand side, just leave it. So verify the, anytime they try to pick the side to verify, it's always the one that looks the most complicated. The one that's simpler, no need to worry about that. Okay? So for number two, on top of that page, then once we get this one done, we'll take a break. Tangent, cotangent. Is there anything that we can do for this one? Should we rationalize the denominator by multiplying its conjugate? Would that work? Or do we need to rewrite it in terms of sine and cosine first? Okay, rewrite everything in terms of sine and cosine? You can do it that way? Uh-huh. Okay. Well, but the thing's that, don't you want to rewrite it like this? I mean, if you do it this way, then that's going to be a lot more work. Okay? So think about the conjugate of the denominator, so we can rationalize it.
Do you want to use the
Yes. Try this. Conjugate, multiply the conjugate. So I got 1 minus cotangent square of y. And then the top, I got 1 plus cotangent of y, tangent of y. And here, cotangent of y plus cotangent of y. So the conjugate, multiply this. So that would be what? 1 minus tangent square of y. What's 1 minus cotangent square of y? Is that one of the Pythagorean identity? Which one is that? Would that be negative secant square of y? And then 1 minus tangent square of y, which is, well, for cotangent, is actually negative cosecant. What about this? Negative secant, right? Okay. So now, what else can we do? Common denominator, which is what? The product of cosecant and secant, right? Yeah. So the product of cosecant and then you multiply this one by negative secant squared of y, top and the bottom. Over here, you multiply by negative cosecant squared of y, top and bottom. But does that help? Things that we can cancel? That's a lot of factor here. Well, let's find out. What can we cancel? It's negative secant y, negative secant squared y. That one I multiplied by negative cosecant squared y. Anything that we can distribute, cancel? What do you think? Well, what happened if you just rewrite them? So this one is negative secant squared y minus secant squared y, cotangent y, tangent y. Extend it all the way. And that one is what? Negative cosecant squared y. Negative times negative. Well, negative times positive. Secant squared y. What can we cancel here? Or things that we can factor? Yeah? Oh, you know what? Forgot one thing here. This one's supposed to be tangent. Right here. This one's I distribute. Right? So this one's supposed to be tangent. This one's supposed to be tangent. That one, once you multiplied it out, so that one's supposed to be negative secant squared, and then tangent. So now, anything that we can cancel? Nothing we can cancel. Anything that I can factor? Mm-hmm. Well, if you try to do it this way, I know it is. Nothing we can cancel, right? Because this one's secant squared, but this one's secant squared. And they're pretty similar. That cotangent y, tangent y, cotangent y, tangent y. Is there any other easy way for doing this? Do you see the easy way for doing this? What happens if I don't want to deal with that rationalizing? In terms of sine and cosine, is that what you're saying? I mean, try to do it this way, we can finish that too, but you have to apply some kind of technique. Okay? Like factoring. Okay? But what happens if I just rewrite in terms of sine and cosine? Again, since there's no Pythagorean identity that I can apply, let's use the ratio identity. What's tangent again? Sine over cosine. So the other one, cosine over sine. Cosine over sine. Complex fractions. How do you simplify the complex fraction? Do we multiply by the common denominator, top and the bottom? Yeah. Mm-hmm. We can just multiply this. Cosine y, sine y, cosine y, sine y. This one too. Cosine y, sine y. Least common denominator. So now, what do you notice? Things that we can cancel. LCD, right? Top and the bottom. So cosine of y get canceled. We got sine square of y over distribute, which is cosine y, sine y, minus, what happened to sine y? Cancel out, so we got cosine square of y. And then the second rational expression, this one got cancelled out, just like cosine y, cosine square of y. And then this one distribute, so we get cosine y, sine y, minus sine square of y. Yeah? Is that what we have so far? Now, what happened to the denominator? Pretty similar, right? Ethan, what can you do from here? You can't. It's a different denominator.
Identity.
Do you conjugate again? Then that'd be more complicated. Well, instead of multiplying this out, so this one, just leave that as a factor. Can we do that? Because you want to combine them together. Well, this one's the same thing, but the part is minus cosine squared y, the other one's minus sine squared y. So what happens if I put it this way? Then the other one, you got sine y. What's the common denominator here? See that this two part, they're pretty close. If we swap them, it's just what? Being negative, right? So the least common denominator would be negative. Cosine y, sine y, and quantity of sine y minus cosine. Would that be the least common denominator? What happens if I just swap this? You guys see that? If I swap them, so sine y minus cosine y. So we need the common denominator, the common binomial, and the different monomial. So now, would I need to multiply top and the bottom here? that would just multiply by negative sine y. Sine qy, right? And then over here, just multiply by what? Cosine y, right? We're getting there. Anything that I can cancel. Or things that I can factor. Check it out. Back to algebra 2. What can we factor? Well, let's just rewrite it. So it's cosine qy minus sine qy. All over that sine y minus cosine y. And then negative cosine y, sine y. What kind of pattern is this? Ethan? Right here. Back to algebra 2. What is this?
Oh, okay, yeah.
So how do you expand it? Right, so that means cosine y minus sine y times, right? Did you get it? The difference of 2q, cosine squared y, plus cosine y, sine y, plus sine squared y. All over this. Okay, guys, getting very close. This tedious for this type of problem. So now, what do you notice? Can I reduce anything top and the bottom? Hey, what happens if I swap the term? This one is just negative, right? So negative 1. What about cosine squared y plus sine squared y? Is that the Pythagorean identity? So for the top, we got 1 plus cosine y plus cosine y and sine y. And the denominator was left. What's negative times negative? Ethan? Calculator, just put it away. What about this? Positive cosine y, sine y, right? What happens if I separate them? Getting close.
I think you can become 1.
Yeah.
1 over.
So it's 1 over cosine y, sine y, plus cosine y, sine y over the same thing, right? You guys see that? So what I did here, I just separated them. So what's the first one? The first one is just like what? Secant and cosecant, right? I know this one is easy. Finally.
Man, that's probably
See that? For this one, programming. So let's say that there's like error right here. And you have to show that, well, there's like a process, like an error that you find, you need to search for it. So you need to go through all the way through to find out that specific error. Programming, debugging. Yes, it takes a lot of time. That's why some people don't like programming. What do you think? What's the degree of difficulty? 10 out of 10? 9? Is it 8, 9? What happens if we try to do it with like tangent, cotangent, rationalizing? That would be even worse, right? Okay, so now what do we take a break? And then the rest of the time, guess what? Yeah? Did you guys register that test next year? Or SAT 1? At least. Right. You guys should be ready for SAT 1. So you guys in chapter 6, right? Chapter 6.
I'm in 4.1. teachers. I think there's
I thought you guys had like a common page.
we will go hundreds and when there's 100 just count.
But she's saying that the other teacher is also using the same test for Michelle. But it's a regular class. And using the test is like an honors test. That doesn't. Really? Yeah. Is she the one that's teaching calculus, AP Cal as well? Who's the hardest teacher for math at Washington? Is that the one teaching Cal PC? What's that teacher's name? Yeah. Mhm. Okay.